shooter for both the PET and now emerging for the Commodore 64. Both are available to try out next door. If you want to come by. If you haven't already come by, come on by. It's been a project probably over the last, well, maybe if I really dial back, just before COVID, I bought a PET, which I had when I was a kid. And if anyone had a PET when you're in high school or whatever, 64 emerged pretty quickly, but you already had a PET, so you couldn't go to your parents and say, like, I want this instead, you know, because it's like they were really nice to buy you the PET and sprung for it.
Which PET did you get?
So it was a 4032, yeah, and no, it was later. Like I got it later, closer to when the 64 came out. So what what I did sort of in awe was like, oh wow, there's like all kinds of really cool games at arcades, obviously, and on an Apple II, and then the VIC and 64. But here I was with my PET, and it always sort of stuck with me that a lot of these games could have been done in the PET back in the day, but either people didn't because the 64 came out quickly, or and it had a much bigger market, or they spent their time on the Apple or whatever. So COVID comes around, and I had bought a PET fairly recently, and I said, I'm going to try and code my favorite game on the PET, and that became Defender, which is sort of, 2019 is when I started it. It kind of probably released earlier, different versions, etc. And you can sort of see, I think probably everybody here is familiar with the PET, but it's all character graphics. You get little blocks that you can use that give you a little bit extra resolution, but it's very blocky. And what I always had this vision was, if you could draw it on the screen, you could probably figure out, something of a way of animating it. So that became Defender. And I was like, wow, that worked pretty good. So some of the other games I was jealous of, these are the Apple II games. Lode Runner on the left-hand side and Choplifter were obviously classics, released in 1980 timeframe on the Apple. And as I said, if you can draw it on the PET, then you can probably animate it. And for these games, I came up with this little 2-character person, which was, I'd never seen it before. Maybe someone had done it, but to this day, I'd never seen really a game that used the little quarter blocks with line characters underneath to give little people who could walk. So once I kind of had this, I'll call it breakthrough, that you could get, a reasonably sized person that didn't need to be like 3 or 4 characters high. You get away with 2. You could make something like Lode Runner, or you could make something like the characters in Choplifter. So those worked out pretty well. Those are available, kind of released them towards the end of 21. Then got a little more ambitious. It's like, wow, Amiga, everyone went with Lemmings. And, with Lemmings, you have a bunch of characters, but again, the same sort of 2 little character high, well, 1.5 really, character set high PETSCII characters. There was no mouse on the PET, so what you have to do is use the WASD characters to move this around, put it there, and then when the little dude walks by, you got to hit it, and you would select, oh, is this going to be turn him into a bomber or a climber or whatever the case may be. So that was like, wow, okay, instead of those 1980s games onto the PET, which were kind of the same vintage, like, okay, this is 10 years later, but it worked out pretty well. So then kind of kept going. Okay, like the NES games, when the original Donkey Kong, it's like, wow, look at those floors. How the heck do you do those? Well, with those 2 1.5 little character people, if you just sort of layer your flooring a little bit like that, that's all one sort of line. But if you kind of put one underneath, you can make it a little bit slanted the way the game is. And that little dude, he sometimes steps on the floor and he makes the floor disappear, or sometimes he floats above the floor. But because it's only 1 or 2 pixels high, you don't really see it. So that worked out pretty well as well. And I got a decent gorilla that I stole the little animation idea from. There was a Sinclair implementation that kind of had a gorilla that looked a little bit like that. And you can kind of, in the original Donkey Kong, everybody knows that first level, but it turns out there's 4 different levels in the arcade game, which I was able to kind of get a decent rendering of on them. That was 2023. And then 1985, Super Mario, and still the same little characters. If you remember in Super Mario on the NES, he grows taller if he grabs certain little presents or whatever. And so in this case, he goes from really short, so that's like a line with a quarter block. That's the original Mario. And then when he picks up that prize that makes him taller, he turns into a 2-character high little graphic, which you see there with the circle as a head, or if he can throw fireballs, I give him an asterisk as a head as well. Came up with a pretty decent boss at the end. That's sort of a Bowser-ish type guy, and he can jump and grab the flag and whatnot. So that one, again, pretty ambitious for 1985 version, pretty heavy graphics. Everybody kind of knows what that original Super Mario looks like. And kind of kept going from there. So then I said, well, what's next? So in this time frame of 92, I'm just going to play a quick video here. Everybody knows what Wolfenstein is, but just for review, first-person shooter. You're kind of holding a gun with this stationary. You're opening doors. You're looking at these walls. There's textures on the wall. Picking up health, going through the doors. There's more health, and you're shooting soldiers. How the heck do you do that? Especially when you consider what was done on PET back in the day. 1981 Rat Run. This came, I think this might have been part of Cursor magazine, but this was sort of state of the art of 3D at that time. It's using the 45-degree lines to give you the perception of depth, redraws the walls. I remember seeing this and just being blown away as you sort of walk through that maze. Similarly, more recently, also similar game, but similar sort of drawing techniques, a little bit more sophisticated with the texturing of the walls, was a game called Labyrinth. It wasn't as popular as Rat Run, or at least it didn't make it up to Timmins, Ontario, where I grew up. But I saw it on YouTube here, which is where I got this video. And that was sort of, again, state of the art. It kind of redraws the floors. And then more recently, someone had taken a game that was 3D Monster Maze, originally written on the Sinclair, and ported it over to PET, and you see a little bit more quicker renderings, but still the same idea where you have the 45-degree lines. So the goal was, how do I do, more of a Wolfenstein, true flexibility on moving around, a lot more real time, and onto the PET using the same kind of graphics. So I'm going to take a little detour. How do these raycasting engines work? What it essentially comes down to is if you have a person looking at a wall, if I'm kind of standing here looking at this wall, you cast a field of vision, and raycasting means I'm going across each, in a sense, in that yellow area. Mathematically, I'm counting how many pixels there would be or how many steps it would take me to get to that wall. A little bit over how many steps, how many steps, how many steps. And you can envision you're sort of building a table to say, oh, there's a wall over there. And generally speaking, it's a little bit longer along the diagonals, but straight ahead it's this fixed amount. And approximately that gives you, something that would look like a wall that I'm looking at, because in a sense it's almost all the same distance to that wall. So that programming technique is called raycasting. It's what was used in Wolfenstein. So then you kind of take that, and here I kind of illustrate a little bit more to say, okay, along these sort of each one of these angles, these different rays that I'm casting, if I'm closer to it, that wall is going to be taller. If I'm further away, that wall shrinks. So you can again envision, okay, along this casting the rays, I know my distance, that I can then map to saying this is how large the wall should be. So that kind of leaves you with something like this. a little bit closer, so I'm looking straight on. You see the wall, and then as I kind of cast my field of vision a little bit wider, those walls are a little bit further away, and I'll talk about how you correct for this fishbowl effect in a second. But that's essentially the very first step. The closer the wall is, the bigger it is. Further away, it's going to be smaller, and you can envision that if that little p moved closer and further away, that gray part would get taller and shorter. Next step, you have a fishbowl effect that, because of how we're doing this, so what you need to do is take a cosine of the angle that you're looking at to correct for this, to kind of in a sense say, oh, although I'm looking in that direction, I'm expecting it to be longer, but I got to sort of pull that wall in a sense. And the cosine of the angle that I'm looking at is at times that distance is essentially what I need for that lookup table. So that sort of, simplistically is how it all works. Do all of these things. You have a top-down map, your player's in a position, cast all of those rays, calculate the cosine, do the cosine sort of fishbowl correction to get the straight wall, and then draw those walls the way I have them. Sounds pretty simple, and I think if I play this, you sort of see how that all works. In this video, it's the same sort of effect as that visibility goes around. They're shorter, longer, you're sort of getting that effect. In this case, they've sort of grayed things out as they're further away, so it gives you a little bit of an impression of being not only smaller but darker, so it's further away. And that's essentially the math behind how Wolfenstein worked. Next step, though, of course, is I'm talking about doing this on a PET. So Wolfenstein was 1992. VGA graphics adapter had 256K of dedicated video RAM. You could do code in 640K RAM. 285. I meant to write 286. Or 386 running at least 12 megahertz, 16-bit numbers that you could add, subtract, and multiply right in hardware. There's no cosine function. Over to my little PET from 13 years earlier. Yeah, a little bit different. Character graphics only, no color, no sprites. 32K total for both code and screen. 6502, 1 megahertz CPU. You can do add and subtract of 8-bit numbers right in the hardware, but there's no cosine calculation and there's no multiplication. But anyone who kind of knows the binary math, you just shift your binary register. That's multiplying by 2 or divide by 2. So there is a multiply by 2, which I actually take advantage of, and I'll talk about in a moment. But that's kind of the challenge. How do you get this sort of raycasting capability, which was earth-shattering, phenomenal game in a 1992 286 with that level of capability into something like the PET. So if I kind of use my mapping of my steps that I described earlier, I start with a top-down map, and in a 256 by 256 map, I save 1 bit per cell. So that's how you use 8K of the 32K for a top-down map that essentially says, in this little cell, there's either a wall or it's empty. There's either something or it's empty. Generally speaking, it's a wall, but it could be a door, it could be a health, it could be something that you're going to pick up like ammo, or it could be a bad guy that you have to shoot. But just suffice for now, for simplicity, to say you're looking at, envision this big matrix that for every bit in an 8K matrix, it's 256 by 256, and it corresponds to it's either empty or a wall. So you could envision that if I put a player imagined in the middle of this, this map, and there's different walls that are stored in memory, I could do a raycasting of kind of going down this path and then going down this path. How long did it take before I hit a wall? Go down the next path. How long did it take before I hit a wall? And in the case of the implementation I've done, you do that 31 times for each one of the columns you'd have that I use on the screen of the PET. So next thing, you then have a distance of the wall, and you kind of still have that fishbowl effect. How do you calculate the cosine? For that, I use a lookup table. rather than obviously coming up with some algorithm on a 6502, I don't have time for that. Like it's just, I got to look up a cosine. So I created a 4 kilobyte table of 16-bit cosine calculations. I'll talk a little bit about how the math works on that table in a second, but suffice to say what I'm doing is a very big lookup table on a cosine calculation to correct from fishbowl effect to get what would be a more straight on a wall like what you see on the right hand side. Some people here, and I know there's a few different people have had conversations about how do you do the frame rates and how do you calculate all of that and how does it all work, and a lot of it is dependent on how far away the walls are. Like if you're in a small room, as you can envision kind of figuring out how close is the wall. If it's closer, okay, I'm done. Next one, okay, I'm done. Whereas if it's further away, it takes longer. But for sort of rough numbers, I can get about 20 frames per second in the implementation that I've done to do the sort of counting of along the 31 sort of steps. It's about 40,000 cycles per frame. Another 10,000 to do this sort of cosine calculation, and then to actually draw these walls is another 10,000. So when you sort of throw that into a PET, you're kind of getting about 20 frames per second. And it turns out to work out quite well. The cosine table, I was pretty proud of this one. I'm using decimal examples for simplicity here. If you need to take this distance that I was talking about, and in this example it's 1,234, and you need to multiply by cosine of 40, well, it turns out that 1,234 is 1,000 plus 200 plus 30 times 4. You use some sort of math property that you don't know the name of, but you learned in high school. It's 1,000 times cos 40 plus 200 times cos 40 plus whatever. And then if you know how to do that, you can sort of say, well, oh, instead of 1,000 times cos 40, if I just look up cos 40, and multiply by 1,000, or in this case, times 10 times 10 times 10, or on a computer, 6502 would be like times 2 times 2 times 2, because I'm be using sort of binary. Could you do the same sort of thing? So you kind of look up the table, and the table becomes relatively small. In this example I've given, if you use every 45 different angles up to 90, and then go from 0 to 9, it gives you a capability of, again, a relatively small table. In this case, it's 450 entries. You would have simplified, of course, because 0 times anything is 0 and stuff like that. But for the purposes of this example, you just sort of store this whole table. It's only 450 entries. Figure out, 4 times cos 40 is 3.1. You look that up. 3 times cos 40 is 2.3, da-da-da-da. And then you do a multiply and add. So in this case, the multiplies are always either times 1, times 10, times 100, or times 1,000. So you kind of do a multiply add, and this is kind of the trick to doing a pretty accurate cosine calculation. In this example, this simple math of keeping only 2 digits in the lookup table gets you to 1,234 times cos 40 is 946.1, and that's approximately equal to 945.3, which is the actual answer. So for a relatively quick calculation with a couple of lookups, a little bit of adding and multiplying, you get a decent sort of lookup. So that leaves you with this engine that kind of gives you the 20 frames per second, which I released around this time last year on my itch download page. And here's kind of how quickly it works as you go around in circles. You can see each one of those lines is one of those 31 sort of distances. Some people who would be familiar with PET, and a couple of people asked about it, the PET character sets are used to kind of give the texture in the wall. And then if you're familiar with the PETSCII characters, you can have like single lines. So what it does to get the effect of a relatively smooth thing, you can add extra lines at the top or bottom. So you take that door right there, it's got a lot of X's with some padding at the top. That's essentially the worst case. There would be, in this example, I'm guessing there would be padding of 7 lines at the top and padding of 7 lines at the bottom, with the X texture in the middle. But then as he goes closer and further, you sort of see that door fills in at the top if you can get to a point. but it's really, very smooth. I learned today, you call that strafing when you go back and forth. You can kind of go around in circles and back and forth. I put a little things that you pick up. That's ammo. I forget in this video. Oh, there's a knife. Yeah, that's the knife. Oh yeah, there you go. So he's going to try and grab the ammo. Yeah, so the ammo lights up, grabs it, fires the gun. I think it'll put an asterisk there, and it counts down the ammo. And then as you go to a door, it'll open the door, which on that bit map, that big top-down map that I described, it essentially is erasing the bit corresponding to that cell. So here it's if you know the first level of Wolfenstein 3D, this is a copy of it, and there's your first bad guy who, there's no sprites or anything, so it's the same sort of characters. In that case, what you saw there was a 3-character tall bad guy. When you shoot him, he flashes, and then he drops his ammo, and you can go pick that up. If you sort of pull back and go forward, he gets a little bit bigger, a little bit smaller, so it gives you a little bit of a perspective on the distance from him. So that's the PET implementation. That's available for download for anybody with a PET. As I say, released it about a year ago. My next project then was to go to Commodore 64. I know there's graphics modes on the 64. I know it has color. I know it has sprites. What I wanted to do was really port the PET version, which is all character based. And so I started with the same sort of architecture, same steps, same 31 columns are used for the walls, and the same sort of math steps. But of course, with 64K memory available in the on the 64, I could make my tables a little bit better, a little bit bigger, I should say. So I'll start with the top-down map. Rather than 1 bit per cell, where the 1 represents something like a wall, door, etc., I actually use 2 bits per cell. So that gives you a little bit more flexibility to say, okay, it's like a 0, 0, it's empty. If it's a 0, 1, it's a door, because and it'll just sort of tell you it's a door, no problem, don't have to look that up. Oh, if it's a 1, 0, it's something to pick up, and if it's a 1, 1, it's a bad guy, basically. So it gives you a little bit more sort of speed in terms of figuring out what you're looking at, because you don't have to, every time you see something, figure out what it is you're looking at. Here it's really just, okay, I know it's a wall instantly, and I just kind of move on to the next column. Casting the rays is the same thing. In this case, because it's a little bit different in mappings, but the cycle's not that different. I use a larger and more accurate cosine calculation on the lookups. So this one is an 8 kilobyte table, so it's a little bit more accurate, twice the size. And then for this sort of lookup of drawing walls, it's more or less the same thing. I make a few little changes just because I use custom characters for the walls, which you'll see in a moment. But for the most part, it's the same thing. So when you kind of work this all through, it gets about 20 frames per second still. It's not an accurate measurement because, again, it depends on the size of the room you're in and how much it has to look and how wait to get to different rooms. And it's taken advantage of, on the one hand, a little bit faster lookups because you're using 2 bits per cell. On the other side, though, this cosine is a little bit more accurate, so because it's bigger, it's going to be a little bit slower. So there's different trade-offs that are being made. But where you end up with is, showing the video here, yeah. So same room that you have before. In this case, there's ammo. This uses custom characters, so that it's a little bit different where you have these lines, kind of giving the effect of how they spread depending on the distance. And I use custom characters for the ammo, and you're going to turn around and pick up, oh, the guy already picked up the gun. Maybe I'll go back. Oops. So these are custom characters on the ground, like that gun. And as you get bigger, it uses sometimes 1 character, sometimes 2x2, and sometimes 3x3 to get this sort of perspective of looking closer. When you go to a door, this uses a joystick, so you don't have the benefit of multiple buttons. If you're close up to a door and you press the button, it opens the door. instead of shooting. But if there's no door in front of you, you instead of opening, if there's no door in front of you and you press the button, it's going to shoot. And so it's a little bit context aware of what you're trying to do, to, in a sense, use the same button. It's the buttons, the joystick's very simple, so you can't really do the strafing with the joystick. You just can only do the turn and go forward. But if you want to use the keyboard, I'm better at it with the keyboard, where I have the full sort of keyboard control, different button, to open doors, to switch weapons, and the keys you can turn and strafe and go forward and backward. Next thing, of course, is because we have sprites, the weapons are done with sprites at the bottom. It's, probably most people are familiar with sprites on 64, where you get two colors. So they're the 2-bit wide ones, two colors, a light gray, a medium gray, and a black. And as we kind of walk through here, the aliens use the same sprite colors, because that's kind of how the 64 works, more or less. And but what I do is I get a third color by leaving some transparency in the sprite, and I shove a character behind it, and I color that character. So when the bad guy kind of gets mad at you, he turns red and yellow when you shoot him, and he turns green when you're going to chase him. I think there will be one coming through this little wall here. They have different, the bag, here it is. So when he's in green, he's in chase mode. So what you're seeing is light gray, dark gray, black border, transparency in the iris, and a character behind that with a different color, in this case green, to show that. The other thing you might be noticing here is it gets obscured by the walls that's in front of it. The sprites don't have a masking. Sprites themselves don't have masking effects. So some people have asked, like, how do I do that? The sprites, you can put a sprite on top of a sprite, and if you make that one a mask, you can, in a sense, it acts like a mask to cover up half. So it figures out where the bad guys are. Are any of them partially obscured by a wall, for example? And if it is, it'll put another empty sprite as a mask only on top of the wall, so it kind of shows half the, in this case it was showing kind of half of that bad guy with the eyeball. So there's a little bit of, obviously a little bit more flexibility and capability on the 64 with the sprites to give a little bit more interesting bad guys that kind of get not only smaller and bigger as you go further and closer to them, but also with the capability of adding color, giving a little bit more, indication of what mode they're in. Whether they're kind of just in marching mode and kind of patrolling, or if they're chasing you when they turn green, or if they're firing at you when they turn red. And again, with that added complexity that you've got to figure out which ones are closer to you to put them first, and then figure out which ones are being obscured by, partially obscured by a wall. So you only kind of see half of it. But it all kind of pulled together, and as I say, it's in the next room if anybody wants to try it. It's not ready for release, but I've kind of got essentially a full level working where you pick up different colored keys to open different doors. There's sort of a, you pick up gold as you go around. You pick up, treasure. Gold is the word I use because it fits in the text. And, there's a mode which I've kind of found kind of fun where you just forget about the bad guys. I call it speedrun mode, I think is, like the coin pickup mode in NES, where you just run through the maze and try and find all the gold as quickly as possible, and it times you, and the faster you do it, the more points you get. So that's kind of fun too. So probably be releasing it in January timeframe once I design some more levels on it, and even just playing it here, I found a few bugs, which is always good. That's all I have. Any questions? Yes. Thank you.
You map out all the walls. So you create the walls, but did you put it in a database? Do you map them out on a piece of paper and then you somehow put it in? And how'd you do that? Put it in a code? So how'd you do that?
Yeah, I used a spreadsheet, so it's done on this thing. So on a spreadsheet, you can envision a big 256 by 256 spreadsheet with little dots of where I want the bad guy to start and where I want walls, and then it just sort of brings that over into hex. Uses copies it into hex, and then I do a cut and paste, frankly, from the spreadsheet. Copy that code. I have it, set up as it's flat. It's a flat binary code.
Then what is the hex? Is that the screen position?
Yeah. So you're looking at it. You have to envision the top down of this level, and in the spreadsheet, a little one would be a wall. So you'd sort of see the walls in this room. Let's just say it's a square. You'd see little walls, and there would be a P in the center where the player starts.
Okay.
And then over to the side of that map in the spreadsheet, if I'm answering your question, it's the first 8 cells of this 250 would be the first byte, essentially.
Okay.
Yeah.
And you draw the walls by going to the upper left part of the screen.
Yeah, use the arrows on the spreadsheet to put a 1, 1, 1 if I want a wall. Sorry. Does that answer your question?
Yeah, kind of.
Oh.
I guess to make the code available too on GitHub?
Well, there's sort of 2 things. Some people have asked for a level editor. I don't know how this is going to work. Let me see if I can. Actually, I have the level editor here. Pretty easy to. Okay, so here's it's Google Sheets, and so there's the little squares that it extends off the screen, obviously, but the little ones are the walls, and that very first room that you saw, that's this room right here. That's the player's starting position, and the ones are the walls. You can see a door here that it's a little bit indented. And this is the gun that you picked up, if you remember, and when you're first looking, you're looking at ammo. So I'm not sure if this is answering your question, but that's the level editor. How I can pretty quickly design the whole level. And there's, each one of those tabs gives you a little bit more detail about, G22, if you can read that. G22 is that ammo. If I were to go to the grab item, this item you grab, it would describe G22 as ammo, and this is how much ammo it has. I would have 15 bullets, depends on which level.
Wow. Can you show us the programming environment too?
Not very easily. The programming environment is CVM Progress Studio. This is a Mac lab, so I actually have it on a PC that I do that.
Yeah, I wanted to see that.
If you want to, it'd probably take 5 minutes to figure out how to. I don't even know if it has an HDMI. Yeah, that'd be easier. Yeah. So use a CVM Programmer Studio, which is pretty common for 64 and any of the Commodore series. Yeah. So
I have it installed. I'm just trying to figure out how to use it.
Oh, yeah. So that's what I use. So in this case, I'll just show you, because you're sort of asking about the code. Yeah. Gotta be somewhere. Oh, so it's not. Yeah, I don't have this on the internet. So normally we'd show the code here. But, that's been part of the code.
Is all your stuff available on GitHub?
No, nothing's available on GitHub. I don't know how to use it. To be honest, if you're going to show me how to use GitHub, I'll show you how to use Programmer Studio.
Sounds like a good trade-off.
Yeah. And I know in Programmer Studio you can automatically save to GitHub. I wouldn't mind throwing up there. All the games are available for download, except for the 64 one because it's not finished yet. And, still a ways to go on it. But all the different, I've emailed the files to people, and, some people have modded them to, I have a Space Invaders game that somebody made into color for the 64, stuff like that.
Oh,
Yeah.
Doesn't the 664 already have a Space Invaders?
Yeah, but somebody wanted to make another one. So here's the code. Like this is sort of that's the code for all the different game items.
Right.
You know, it's just lookup it's lookup tables, and here's the code for that. The byte representation that I would just sort of put into the assembler for the level.
Cool. How many levels are there?
I've only done one so far.
Well, I mean, how many levels are you gonna do?
Oh, maybe 10. It just loads them off a disk, so we can put as many as we want.
So when it goes to the next level, you load it off the disk?
Correct.
That makes sense.
Yeah, and you know, if somebody wants to develop levels, I can give you access to this level editor. And I've even sort of embedded it where when you load the level, it says who the designer was, so I have in mind. If somebody else wants to develop levels, like great, like have at it. So,
on the PET, how are you doing the collision detection? Like if you fire, how do you know you hit?
Or how do you know to keep the character from going through a wall?
Two separate things. So in that lookup in the ray scanning, if you hit a wall, you hit a wall. There's nothing else. You're gonna see a wall. All right. So if you think of that step, if you hit something that's a so-called item, so whether it's a enemy or something that you're going to pick up like ammo, it shows up. You know, you store that in a table to say in this sort of that direction, I've seen a piece of ammo that I'm going to pick up. Okay, thank you. Record its distance, but keep going until you hit a wall. So you sort of have at the end of that first step, if you remember those 3 steps I had. At the end of the first step, you have 2 tables. One is, and they're only 30. It's only 31 rows. Table 1 says, what's the distance to the wall? The second entry is, in that row, did I see like an ammo or whatever? And if I did, how close or how far was it? So you know how to render it. That's the first thing. So when you shoot an enemy, if your gun is pointed here, if that middle column of the 31 that you're rendering, if it has an enemy in that second row, that guy's going to get shot. If it's, on the other hand, if you're pointed over here and there's nobody there, he doesn't get shot. End of story. So it's pretty quick to know when you're shooting something. When you're walking around and to pick things up, I think was your question, that 2D map, that top-down map, it just moves the character through that. It's a little bit more sophisticated because there's fractional movement, but simply put, he's moving cell by cell, and if he happens to walk into a cell where there's something, if it's a wall, he's not going to move into it and he's back along. If he walks into a cell and it's something that's not a wall, like a hammer, and just picks it up and it erases it from the map and puts it in your pocket.
So the illusion, the game is the 3D part's just an illusion, and you're still handling it like it's a 2D game, basically.
Yeah, in many ways. Like I think like as I learned about this, like this raycasting, like
Now I get why Doom already had a map.
Yeah.
If they're rendering the game off.
It is. Yeah. I learned today. Doom's a little different, but if Wolfenstein,
2D game, 3D part is faking it.
yeah, like Wolfenstein stores that as a 2D, and you're just wherever you are, you look for the walls, and just as you turn, just keep looking for more walls and draw them in a 3D way.
There was a video recently that somebody did about that, like a YouTube video, I remember Ron or something, about 3D graphics on those. I was talking, it's from that top down. I can't remember who it was, but it was great.
Just hands it.
Yes.
I think was there a question?
Oh, I was wondering, can you have more than one enemy at a time?
On the 64?
Yeah.
Yes. Yeah, so there's 8 sprites. 3 are used for the weapon at the bottom that you saw. 2 for the weapons, and the third one is the explosion when you fire. It's kind of red or it goes red-yellow. That leaves 5 for enemies. So what it does is, that same thing I was describing a moment ago, as you kind of do that scan, and if you see 6 enemies, it'll figure out which ones are closer, and it goes in whoever's closer first. Once it gets to 5, we're done. If there's a 6th one in your visibility, you're not going to see it. My hope is you've shot everybody. Like in general, there's only 2 or 3 enemies are in a certain area, but in theory, you could just run, and they'll keep following you through the maze, and they can open doors, and they'll keep following you, and you could eventually get to a point where there's 6 or more enemies in a room with you. They're probably, you're only going to see 5, I'll tell you that, like factually, but, if there's some are closer and some are further, they may obscure each other anyway, so you got 5 things to worry about. Start shooting what's closer to you and what you see, and whatever. It's the best I could do. And the other thing, I use some of those sprites for the masking. The way the algorithm works is it'll render whoever's enemy is closest, whichever ones are closest. If there's only 5, it's going to use all 5 of those sprites for those enemies, and there's no more left for the masking, so too bad. It's not the best representation. But it'll use, say, 3 sprites for 3, and then it'll use the remaining ones left for the masking if you have one. So I try to design a level a little bit more where you can be a little bit flexible, but there's 2 or 3 enemies in every general area. Hopefully you kind of deal with them and you move on, and you'll see more enemies, and you never really get to that point.
But that's in the C64.
Yeah.
So on the PET version, can you have more than one as well?
Yeah, because those use characters. So in that second little array that I was alluding to, if there's like an enemy in every one of those visions, like it's just going to draw like 31 enemies. Doesn't matter. It'll be slower.
So I was kind of getting at.
Yeah.
How do you account for frames that everything is close and rendered quickly versus all the walls that are further? How do you add delay?
No, just go.
Everything?
Just go.
Just go?
Just keep going, yeah.
Okay.
Yeah, not that sophisticated.
Okay, so when you play, it'll appear to slow down a little bit in
Oh,
some areas?
sorry, I understand your question better.
Yeah.
So it'll keep rendering it as quickly as it can try.
Yeah.
Separately though, 64 and the PET have an interrupt.
Yeah.
So the interrupt is what you move. Like, so when you're turning, you're always going to turn at the same rate. So your own motion is quite constant. So if it's rendering a frame and you try and make example, say I'm looking this way,
Yeah.
and its walls are very far away, and then I turn, it's going to start rendering it again because it's always going, always going. It might get halfway, and then all of a sudden I turn again. It's just going to sort of pick up where I left off. So it does look a little chunky. If you come in there, I can show you one of the rooms where the walls are far away, and it kind of goes like that. But it's not really noticeable, and it's like good enough, yeah. But at least your motion is consistent because of the interrupt. Like the interrupt, your motion, your firing, it's always real time. It's more that the rendering is catching up with you, and hopefully it's fast enough if you're in a small enough room. Yeah, it works decently, and the times when it's chunky, that's it's a really long hallway, pretty wide, you can envision, and the person's going like this pretty quickly. It happens, but...
Would you say that the bulk of the wizardry that goes into there is about being the wizard of trade-offs, and mastering your trade-offs to hide any,
Yeah, to me it's like a puzzle, like how do you fit this into 6502, 1 megahertz, And like I know there's better machines like RAM extenders, or obviously like even newer computers. To me it was just sort of a challenge of getting these things onto the PET, because that, for me, that was the origin. Like I was like, 16, 17 in 1980 or whatever, and it's just like, wow, I can get some of these games that I was just like salivating over onto this machine, and it's like, that was the challenge, like fitting it in and doing the trade-offs and getting it close enough, working with the little character set that you have. 64 is obviously not as limited, you have color and stuff, but it's still somewhat limited. So yeah, to me, that's the enjoyment of it. Yeah. Yes.
So with CVN Studio, you're taking this Excel spreadsheet, dumping it into CVN Studio, and then you're building, right?
Yes.
This particular file is a separate thing that CVN Studio will export to a binary file as the map?
No. I will design the map on the spreadsheet,
Yeah.
and then I'll just copy and paste that. Actually, this is the map itself.
Right.
So the map's done on a different tab, which I showed a moment ago.
Yep.
And then the spreadsheet just creates that, like byte, and then I just copy that, literally copy, email it to myself, Email it. Yeah. You know, open the email on the.
We're gonna have to talk about this.
Zip files and floppies.
Yeah. No, I retype it.
Nice work, huh?
Yeah. Does that answer your question though? It's just,
I'm just
it's only a one-way thing. Like
No, I understand.
Yeah.
You're talking about, or with the suggestions about the map generator and
Yeah.
all that, and then having everything dumped to a particular file
Yeah.
for each map. I was just wondering, like, is there something in CDM Studio that's reading this, writing it as a binary file that's written to the disk image,
Oh,
and then how is it manifested for multiple levels in
Oh.
the future kind of deal?
yeah. CVM Program Studio, this would be one file.
Yeah.
You write it out, and in this case, it's called like level 1 map,
Yep.
something like that. You know, hit assemble, it creates a .prg, and then and then the actual game will load it, you
And
know,
dump it into memory.
and dump it into memory where I need to do kind of like the ROM call of load
Right.
level 1 map,
Yeah.
comma 8, comma 1.
And the map is in a static place in memory.
Yes. Yeah. Yeah, exactly.
That makes things easier in my life.
Yeah. Okay. Okay, thanks everyone. Oh. Okay.
Yeah, go ahead. I was just going to ask, the code that's above this, that's not the whole game code. There's more game code, I'm assuming that's not a part of the spreadsheet that
Yeah.
you're including.
Yeah, this is only the code for the map and for the items in the map.
Okay,
It's
so
just sort of a lookup
if
thing.
someone wanted to, they could like dynamically program their own item that does its own thing because of the code that exists there?
No, when I say the code for the items, it's like, it's essentially what's the X and Y coordinate of the ammo.
Oh, okay.
Right, so it's like, that's a wall at the top, it's, if you don't know if you can read it, but it says, there's 7 walls in this level. What direction does it open? Like you push, it's one of those hidden walls like in Wolfenstein, so you push the wall.
Right.
So does it push north, east, south or north or whatever? And then what's the X and Y coordinate of the wall? So it's not code, it's just a
Right.
table of locations.
Config file.
Okay.
Yeah, config file, yeah. Yeah.
Thank you.
Okay, thanks everyone.
That's cool.